Good morning, good afternoon, and good evening to everyone who is watching this show from different parts of the world. I know that's the reason I always say good morning, good afternoon, and good evening. This is your host Rajiv Kulkarni from Dallas, Texas. Central Standard Time is 9:02. Today we are a little late by 2 minutes to get it started. However, but we are here on every Friday talk show at 9 a.m. Central Standard Time of US or 7:30 p.m. in the Indian time right now. So the basic idea of Global Electronics Friday talk show is to bring various topics on electronics manufacturing, whether it's design related, whether it's market related, quality control, challenges in the manufacturing process, and so on and so forth. And every week there is always a different topic, as I mentioned. And today's topic is why is the V model important for Ultra HDI PCB design? That's what we have mentioned in our poster as well as YouTube link. So designing Ultra HDI PCBs present significant challenges due to their complexity. Routing congestion, high component density, and fine features lead to intricate routing challenges. And they're like signal integrity issues, fine traces, high speeds, and dense layouts, and so on and so forth. There are many factors involved, and that is why we have an expert from the industry. And he is been with us for a few shows already now on Global Electronics. And he comes from Silicon Valley of India, that is Bangalore in Karnataka state in India. And he has a wealth of experience in the design and manufacturing and assemblies and so on and so forth in the electronics manufacturing and electronics industry for more than 4 decades now. Mr. Ambaprasad, technology consultant from Bangalore. Welcome to the show, Mr. Ambaprasad. How are you this evening?
Yeah, doing good.
Very good, very good. I hope it's not raining in Bangalore today.
Yeah, it rained off and on. It's raining almost
So
every day.
it's raining almost every day. That's in a way it is good, but if it exceeds too much, then definitely sometimes it can be an issue. But that's anyway. That's related to the weather conditions, and today we'll again share the screen of our topic here. And as probably you all must be seeing this uh, particular screen, if
Go to full size,
yeah, we'll go there once I
arrow,
open the required
arrow on the top
page.
left.
Yeah, I will go there once I get onto the required page. 22. That's what the topic of discussion today. Yes,
Yep.
I guess this is it, right?
Yeah, that's it. Yeah. You can, no, you can just go to sheet number 12 directly.
Oh, sheet number 12. Sorry.
Yeah.
Let go to that. So here we are talking about V model applied to system design.
Yeah. I got a full size.
And
Yes.
okay, so Mr. Amba, actually, I have, before you start this, I have a couple of questions already. Somebody has sent me. What exactly is V model? And the second question to follow with that is how important it is for the Ultra HDI design in the PCBs.
Yeah, it's a good question, especially for people who are from Bangalore, English medium educated. When we say model, a model has got a lot of meanings, at least in Bangalore circles. So we say we take model interchangeably with a lot of things. I mean, we used to call cars on model, Mark 1, Mark 2, Mark 3 models, and they were models and they were role models, things like that. So let's say what is a V model? V
Yeah,
model generally came into existence for software development, a program development. On the left side of V arm,
uh-huh.
we just see the implementation. We decide what to do first. We put all the boundaries and we define the specifications and all. And at the bottom vertex, we just do it, we just implement it. And on the other, on the right side of a V, it is generally it is a sort of a downstream activities. We do testing, validation, system testing, and integration and stuff like that. So on left side of V, you have a upstream, then the actual implementation and the downstream activities. This was applied I mean, people started projecting it for a lot of things. One of them is system design. It is being applied. Go to next slide, please.
Right?
Slide 13. You can type 13 over there where 22 is there and
This is
yeah,
PDF, right? So yeah.
yeah, it is a PDF. Yeah, go to full size.
Oh, wait. This is not 13. Okay.
So, yeah. Okay. So view model is even say 5 or 10 years back, the aerospace industry and automotive industry, especially on the automotive ADAS control unit and all, not the EVs, the actual classic automotives where they had electronics to control ADAS and ECU and safety systems. They started implementing a V model so that they know where to apply the standards and how to validate it. That became very popular over there. And since that PCB is also a part of this kind of an ecosystem, the same V model can be extended to Ultra HDI designs. Of course, it doesn't mean that we should not apply V model to a regular classical design also. It can be applied anywhere. But it becomes very much important. It becomes absolute necessity in Ultra HDI because of the features what you told in the beginning, a finer trace width and gap, and a very well defined via structures and signal integrity, power integrity challenges. And there is what is called as the structural integrity. It is very much important. Okay, that's why the V model comes into a key role. And V models are already integrated into CAD systems and CAM systems. Okay, let's define what is Ultra HDI PCB characteristics. What is the differentiator between Ultra HDI and say HDI PCBs? This may sound like a repeat for some of the persons who are following our channel. But anyway, those who are new or even for the people at the refresh, any trace width less than 50 microns, trace width and gap, which is less than 50 microns, even almost going towards 25 microns, is Ultra HDI. And microvias, less than 3 mil, 75 microns diameter. This cannot be mechanically drilled. It has to be laser ablated. And again, I want to just remind you, Rajiv, that when we say 75 microns, almost 70 microns is a 2 ounce of copper thickness, which we use in a regular PCBs for power supply. So now we know almost the, we can imagine the size, how much it has come down to.
Yeah,
And then the dielectric
that's right.
layers, which are less than 50 microns. People have gone less than 50 microns, but UL is stopped approving anything less than 50 microns. If you want a UL certification, you have to stay at 50 microns or more. So that's why it is sort of stuck over there. And the usage of high performance material. People no longer use FR4. They use engineered materials. In fact, some of them are glass based and some of them are Teflon based. So these are the conditions for a Ultra HDI PCB. So when all these things are very costly technologies, precision is very much required. And by design, if we don't follow certain design disciplines, things will go out of hand very soon. and we'll be walking away with a zero in our pocket as early as possible. That's why we have to just follow V model. So this is latest IPC 2226, which says it is giving a BGA bump pitch at the bottom, and again like line space, line width and space in microns. And again, we are today at about 350 microns bump pitch on a PCB. And then there it says we cannot do anything negative processing. We cannot do etching and all negative. We have to go additive or a semi-additive process. That's why it is stopped over there. And now negative cannot happen. Everything is positive. Basically, we are entering a semiconductor type of processes, and only OSAT fab houses can do this. This is a roadmap, technology demonstrator done in US design houses and even in Europe. Right now, readiness level 1, 2 microns, line width and space, bump pitch is 25 microns on Ultra HDI, via diameter 5 microns, through substrate via 35 microns, a layer per side, it is 3 plus n plus 3, and maximum thickness is 0.8 mm. And again, technology level 2, it is 1.25 mm. Then finally, technology level 3 and 4, we are hitting a classical 1.6 millimeter PCB thickness. The key here is your Ultra HDI may coexist with some of the earlier PCB technologies. They may coexist in the same PCB layout, in the same PCB outline.
Interesting, very interesting.
Yeah, this is the V model applied to Ultra HDI PCB design. On the left side, you have requirement analysis, high-level design, all done at a CAD level, detailed design done in a CAD level, then the actual layout, and then you do unit testing, integration, and system testing, validation. So these are all cross-linked. And
Excellent. Let's take a quick break here and then we'll continue. Welcome back to the Global Electronics Friday Talk Show with your host Rajiv Kulkarni, bringing you every week different topics on electronics manufacturing. As today's topic, as you can see, the first 15 minutes, Mr. Ambaprasad, who is a technology expert from Silicon Valley of India, which is in Bangalore, Karnataka state in India. And today's topic was V model and its importance in Ultra HDI design in the PC boards. And there were like very interesting some slides that he went through, and we'll continue our discussion. Ambaprasad, welcome back after this small break, and let's continue our talks here. Okay, So we have this here, V model applied to
Yeah, yeah, yeah.
Ultra HDI
So
PCB design.
let's stay there for a moment.
Mhm.
Lot of EDA companies have started implementing a V model in their workflows, and even DFM routines they are implementing V model. So one important aspect on a V model is when we are on the left side of the V arm, we should. It is very good if we remove unimplementable attributes and repeat attributes. If we remove them, life becomes easier later on.
Hmm.
Next
Interesting.
slide, please. Yeah. Now I am telling why the wave model is important for Ultra
Ultra
HDI
HD PCB design,
PCB
yeah.
design.
And
I should,
actually, it was one of the questions initially
yeah,
I
yeah,
had
yeah. This
indicated.
slide
Yeah,
covers that.
yeah.
If I ask the question myself, why the V model is important for Ultra HDI PCB design, the straight answer is why not. I mean, I can tell in maybe one word, why not? But yeah, let's for the routing congestion. High component density and fine pitch features lead to intricate routing challenges, and especially the bump map and breakout region. These are the two regions where routing is very difficult, trace routing,
Hmm.
because we have to follow standards defined by JEDEC or somebody for memory modules or some standard protocols and the outlines, and it becomes very challenging. People are addicted to pin swap and get swaps earlier. They were
Hmm.
changing assignments the way they liked, but that's a sort of a tough nut to crack here. Routing congestion, signal integrity issues. We are almost uh, hitting microwave type of signal integrity problems at gigahertz range. Thermal management, it is always there. Things get heated up while manufacturing the PCB, as well as assembling, as well as in service. Manufacturing complexities. I told earlier it is a laser drilling and semi-additive, and a lot of leading OSATs and PCB companies have got their own secret sauces which they are not putting in the open. One assembly house can do it and other assembly house cannot replicate. And maybe the same company, a different branch in some other city, it is becoming some sort of a secret sauce. Okay. And cost and risk. When we say cost and risk, the cost and risk can be implementation cost, non-implementation cost, or we have to uh, prove it actually. I mean, scale up is a big issue.
Hmm. Hmm.
Basically, the first 10, 15 prototypes may work. Then when you take a leap of faith and make about some 100 and 150 models, they start behaving slightly differently. So this is one that is where the V model comes into picture, especially it is tightly integrated with the digital twin. It really makes life easier. The V
Interesting.
model addresses these challenges by integrating
Integrate.
testing and verification parallel, so that in development phase, promoting early defect detection at a higher chance of success. So this is the final statement which I have given.
Okay, great.
Next slide,
So
please.
the next slide. Yeah.
Go ahead with your question.
Well, the question would be you mentioned about the thermal management there,
Yeah.
right? So now in the V model,
Uh,
of course, it's very important Ultra HDI PCB design. Why? So how thermal management plays an important role there?
Right now, when we are talking of Ultra HDI thermal management, we are still considering uh, insulated metal substrate only. We are not
Hmm.
getting into liquid cooling sort of a thing. Liquid cooling comes into picture. That is the next step actually. That is heterogeneous integration. So right now it is restricted to some sort of IMS sheets only,
Okay.
insulated metal
And
sheets.
what about like liquid dispensing materials like silicon, like gap fillers or
Yeah, they come under between the actual chip and the layer one or the bottom layer of the substrate. Yeah, it is also very much important. Yeah.
yeah, because I think those comes
Cleaning
under
is
the
also very
advanced.
important.
Yeah.
Cleaning is very
Advanced packaging.
important.
Yeah,
Yeah,
cleaning
yeah,
is all.
cleaning, encapsulation. If your encapsulation also can act as a thermal stuff, it is very great.
Mm.
All rolled into one.
Okay, wonderful, wonderful. And of course, on the signal integrity, I find
Mm.
that definitely the fine traces, like the tolerance of the trace width and the
Yeah.
trace, right?
Mm.
So, how critical is that? Because now the circuits are getting very dense and the circuits are getting very, very small and small because very high intelligent, high power devices and the ICs is being used for various applications, right? Because of now we are talking about AI enabled devices. So now from that perspective, what like fine traces plays a role in this particular design level.
Yeah, this is a real dichotomy. On one side, we are telling make a trace width as less as possible.
Yeah.
But if you go to a sort of a classical signal integrity requirement, you require a wider trace to have a better skin.
Yes,
Okay,
yes, yes.
so this is a very tightrope walking. Okay, and tightrope walking without band playing.
With-
So in circus, they do tightrope walking when the band is playing, but here band is not playing. You have to walk in silence. Number one. Number two, people have solved this problem by using engineered materials, and materials
Mm,
don't have any defects. They don't have any pits and scratches. So I mean, it is no longer a black magic. It is proper engineering. Advanced materials are available actually,
mm.
but at a
So
cost. It's very costly.
now I come to the next level. The PCBs comes in array, right? When they come
Mm,
in array, and those needs to be singulated, right?
mm.
So now, what kind of tolerance is there? Are we talking about when I remembered this question because of when I saw the routing congestion, but here the routing congestion is different than what I am talking. So I am talking about singulating the PCBs in a high
Yeah,
dense
the
circuits.
simulation routing. Yes.
Yeah, singulation routing, right? So what kind of tolerance between the boards or between the when you do the singulation? Because when you put the spindle,
Mm.
because routing is normally done either with the CNC or the router, right?
Yeah.
And so when you put the spindle, definitely there can be a mechanical stress which
Yeah, yeah, yeah.
probably might apply on the components, right? Because these
Yep.
components are so delicate. And so, what is your suggestion that how this can be handled?
See, the actual there is a groove, and on the groove nothing should come.
Mm,
That's a valid statement. But the
mm,
groove is no longer in mils; it is in microns. Number one. Number two is even in silicon when they do dicing, they leave some gap, okay, for the wheel to move. But in that region, they put some coupons and all that area so that the area is not wasted. That's the only way people save. But one thing is here, we cannot pack as many PCBs in a panel as possible. The number of
yeah,
PCBs per panel are going to be less.
right. Okay, great. So I think that's all the questions I had from
Yeah. Three more
my.
slides after this. Uh,
Okay.
V model applied to Ultra HDI PCB design. The V model is best suited for projects that require structured development, rigorous validation, and high reliability. People have to do co-work. In the layout, designers should act like a process engineers and managers, and process engineers also should have some layout prescriptions. They should visualize that it is not putting the blame on the previous activity like that. It has to go as a sort of, it is multi-physics and all. People should stop blaming each other. They should come out with a solution. Earlier, it is the better, especially on the upstream. Yeah, okay. It works well when requirements are clearly defined upfront and when compliance with industry standards is very critical. You have to follow the
Mm,
industry standard. In fact, a couple of weeks back, I met one person. The person said his main complaint on the standards was he was telling standards are always a little, maybe they are 6 months behind the industry. That is true because we need some consensus. Everything cannot be state of the art. It should be
Yes.
implementable. Whether you buy a white paper in Avenue Road or in MG Road or in Gandhi Bazaar, it should be white paper. It should be pure white whether you buy anywhere in the world. So that is standard. Okay,
Yeah.
that should be the case. And Ultra HDI PCB development is well suited for a V model to meet product mission profile. You should know the mission profile upfront. Okay, ensures verification and validation at each stage, helps mitigate ECM. ECM is a electrochemical migration which we covered about a couple of months back, is still a
Yes.
major threat. And thermal runaway.
Hmm.
Again, your favorite subject thermal is coming back. Things may get too hot. Perfectly the
Hotels.
V model perfectly dovetails with the feed forward principles and predictive assembly optimization. If you are using AI, you can predict what is going to happen. Feed forward is much more important. Please go to the next slide. Yeah, it is. This is a very good statement. The V model is ideal for complex identity designs where feed-forward mechanisms help anticipate assembly challenges. Okay, PCBs are built for assembly also, not only
Hmm.
sort of SI and all. It should be structural integrity is very much important. Suited to work well for exploratory designs. If you are trying to do something new, it works. Where signal integrity adjustments and thermal requirements evolve dynamically, especially uh, thermal aware power integrity. It's called as thermal aware power integrity. Applied while exploring predictive analytics in PCB fabrication, integrating proactive workflow principles into validation stage, it should enhance process refinement. So
Hmm.
people generally use digital twin where you get actual yield feedback and try to tune the layout. Next slide, please. Yeah. V model applied to Ultra HDI PCB design. Why? This I could have explained in the previous sheet, but I wanted to highlight here. The V model is structured approach is especially beneficial for Ultra HDI, where high density interconnects and fine pitch components and advanced materials, C3 separately, demand rigorous process validation because each of the above, though contribute in densification, however, when as a cocktail, when they come together, okay, they create a very volatile mix actually. Sometimes it works, sometimes it doesn't work at all. You try
Yeah.
to, now here the component will point fingers at routing will point fingers at a material, and this has to work as a unit. Yeah.
Okay.
Next slide, please.
I think we are done.
Yeah.
So I
Next
think
one, next one. I think that's the last one.
yeah.
Yeah. So when we are exploring predictive analytics in PCB assembly, integrating AI-driven workflows into the V model validation stages could enhance process refinement. Further considering applying RF and microwave. Here I was keeping quite still. When we say ADAS and sort of
Yeah.
sensors and things, even RF and microwave, which has got its own intricacies, that will also start to contributing towards the system attributes. And it's a very good exciting. It's a very exciting, very volatile combination. It clicks, it works right the first time. Otherwise, you try and till the cows come home, you try tuning, it won't work. That's why the V model is one of the best approaches. We are going to talk about V model in the next session on the left side of the V and right side of the V. And yeah, that is end
Okay.
for the day.
Excellent. So next session we are going to uh, I mean next week. It will be next week. And what exactly will be the topic, Mr. Amba?
I'm going to explain the left side of a V first, and then I explain right side of the V.
Okay.
And anyway, any message you have
Excellent.
for the audience?
Excellent. Now, any more questions? Audience can definitely shoot questions if they would like to know anything else. It will be our privilege to answer you with any questions that you have. Somebody mentioned that very informative session. Thank you so much for the lovely comment like that. And I know that quite a few people were online watching this show. Thank you very much for all your time watching the show. Please do subscribe to the channel because we bring in very informative, very educative topics every Friday, same time. And it will be a session for 30 to 45 minutes. And if any one of you also want to participate, please do message us. And it is always mentioned in our YouTube link as well as the poster in the YouTube. You can message, that's a WhatsApp number. Also, you can email if you would like to be a part of this talk show. Because the whole idea of Global Electronics Friday talk show is to share the wealth of knowledge from our experts in the industry so that others can, the younger generation can get benefit out of it from our experience, from our knowledge that we have learned so far. With that said, thank you very much, Ambaprasad, for your valuable time,
Yeah,
valuable
I have two
input.
messages.
Yes, please.
One is I'm telling people don't sit and clap and enjoy. Come and join us. Let's have come into the field, come into the arena. You start presenting. Maybe going forward next year we can have it as a two or three experts participating in one session. That will be
Yes,
very
sir,
good.
like a panel.
Second thing is,
It can be a
yeah,
panel
like a panel.
discussion.
Today we have taken a leap of faith on V model and things on a very important day. Today is Friday the 13th. Okay,
It's
so
a very
uh,
good day actually. Very good
yeah,
day.
it's a very good day. It's a very good day for the skeptics, and it is very good day for inspectors and people who always, who inspect things and who always suspect something in the design. It's a very good day
Right.
for them. I think they'll be having a field day. I enjoy the show. Whether I think I mean the feedback what I got from others was people were enjoying the show. They gave me a lot of messages in person also.
Uh-huh.
And anyway, we'll meet next time. Be ready with the questions. And yeah, that's it.
Yeah.
Thanks.
Okay.
Thanks a
Thank you
lot.
very much, Amba Prasad, for your valuable time, and thank you all the audience who joined us today. And we will come back with the next follow-up session or the 2.0, I would say, about V model and its importance on Ultra HDI PCB design. With that said, have a wonderful weekend, and wherever you are, be safe and God bless all. Thank you very much.